Okay, so here's this block sitting on the surface, right? And now we exert 35 newtons of force. Well, 35 newtons is bigger than this static friction, right? So 35 is bigger than 23.03. So this force breaks, right? It's gone, and now this thing starts to slide to the right. Well, as soon as it starts to slide to the right, the kinetic friction force takes over, right? And just like you saw in that demonstration, right? So we now have a force of 8.33 newtons this way. So this is by the way our kinetic friction. Okay, we calculated that in, I don't know, part A or something like that. Okay, so I notice that it's sliding to the right. That makes the kinetic friction to the left because it always opposes the direction of slide. This is to the right because it says to the right. Okay, so because it's to the right, I make it positive. Because that's to the left, I make it negative. Okay, and now we can just add up all the forces, right? We've got an applied force of 35 newtons, and it's positive. We've got a friction force of 8.33. It's negative because we're sliding to the right. The friction is to the left. Okay, and then that equals 5.00 times a. So this is an unknown acceleration problem. So I'm going to go 35 minus 8.33, 26.67 equals 5a. Okay, so divide by 5. And I get that the acceleration is positive 5.334 meters per second squared. Now we have to answer the question, is it accelerating or decelerating? Okay, so notice that it's sliding to the right. It's got a positive velocity and it's got a positive acceleration. That means it's accelerating. It's going faster and faster. It's going faster and faster. Okay. Another way to look at it is just look at the forces. You got more force in the direction it's going and less force opposing, so it's going to go faster and faster in that direction. So those are the two ways, right? In general, when you do this, right, if you've got a positive slide and a positive acceleration, then you are going faster and faster, right? If you have a positive slide, that is, you're sliding to the right, and a negative acceleration, then you are decelerating, right? Okay, if you have a negative slide and you have a negative acceleration, that is, this number comes out negative, then you are slowing or decelerating, right? Oh wait, sorry, no, that's not right. Then you're going faster and faster, right? Okay, if you have a negative slide and a positive acceleration, there we go, then you are decelerating. You're going slower, you're slowing down, okay? So when the slide direction is the same as the acceleration, you go faster. So negative, negative, faster. Positive, positive, faster. When they're in opposite directions, if you're sliding to the right and accelerating to the left, you decelerate. Or if you're sliding left and accelerating right, you're decelerating, okay? That's the rule. You could also, I just look at the tug of war here, by the way. That's my way of doing it. But